Hello from the children of planet Earth.
I'd like to extend the greetings of the government and the people of Canada to the extraterrestrial inhabitants of outer
Hälsningar
space.
från en dataprogrammerare i den lilla universitetsstaden
From my point of view, the search for extraterrestrial life, and especially the search for extraterrestrial intelligence, is one of the key philosophical, scientific, and human questions that have been posed. But we are at the
Let's start here, on the top of Mauna Kea in Hawaii, where the W.M. Keck Observatory scans the clear night sky. Carl Sagan knew what explorers have always known. By understanding more about our neighbors, we will understand more about ourselves and our place in the universe. No one knows Sagan's vision more than Lisa Kaltenegger, the director of the Carl Sagan Institute at Cornell University.
Carl Sagan and his approach to science inspired me. We are using many different fields of science: astronomy, chemistry, biology, engineering, and many more to make a forensic toolkit to understand our place in this fascinating universe.
Before the Voyager spacecraft left our solar system, it made some remarkable discoveries. It proved that we need to be more open-minded about where we search for alien life. In 1980, Voyager first reached Saturn. a raging ball of hydrogen and helium storms. Not much chance of finding life there. Voyager then turned to one of Saturn's 62 moons. Capturing the first close-up images of Saturn's largest moon, Titan. What it saw stunned astronomers. Titan had a dense atmosphere, mostly made of nitrogen. 24 years later, the Cassini probe revealed even more. On the surface are vast lakes of hydrocarbons, the building blocks of amino acids, proteins. Cassini continued on its celestial road trip, where it found this frozen outpost, Enceladus. This moon appeared to be frozen solid, a dead ball of ice, until something astounding was spotted near the South Pole. Huge plumes of water spouting through cracks in the surface ice. Beneath the frozen surface of Enceladus was an ocean of liquid water. It turns out that planet Earth doesn't have a monopoly on water like we once thought.
On Earth, water is key to life. It abounds on our planet, and every animal, every plant, every life form depends on it for survival. The seas are where life was born. Water is the lifeblood of existence. On Earth, liquid water is critical for life forms that live in it, as it is for those that live out of it. When we search for alien worlds that might support life, the presence of liquid water is a critical clue. If a world has liquid water, there's a chance for life. Biologist Chris Johns knows the fauna and flora of Hawaii really well, including some amazing examples of the extremes life will go to survive.
A stretch of barren lava rock. It isn't the first place you'd expect to find life. But that's exactly where nature has hidden a few surprises.
These lava tubes extend for miles. They were created when lava drained out from an ancient volcanic eruption beneath a crust that hardened above. This is amazing. A whole new Hawaii I've never seen before. A secret, hidden Hawaii.
In this upside-down place, you have to look up to see the roots of the remarkable ohia tree.
They're beautiful, hanging down into the caves like sparkling jewels.
Yeah, so we can actually check out some of these microstructures.
And they sparkle because they're covered in water. Moisture that has condensed from the humid air. Life needs liquid water to survive, but the ohia tree shows us that it can be very innovative in the way it finds it.
For our data collection. Even something
This is the Haleakala Valley on the island of Maui. NASA uses alien landscapes like these to test their Mars rovers before sending them off to the Red Planet. The soil here is made of cinders. The altitude is over a mile high. And the weather is dry, sunny, windy, and freezing. It's the last place you'd expect Mother Nature to start gardening. This is the Haleakala silversword. Its fat leaves store water and are covered with tiny hairs that pick up humidity in the dry air and send it down as liquid water to the roots. Water as liquid, or carried on the wind, or coursing across the landscape, makes Earth a thriving paradise of life. Water, with a dash of carbon and a little energy from the sun, are the simple ingredients for life to blossom. In the canyons of this undersea world, there is no sunlight and the water pressure is, to put it simply, bone-crushing. And yet, more than a mile down from the surface, life flourishes. These hydrothermal vents leak out heat and minerals from the Earth's core. They're called black smokers and ooze clouds of sulfur, which is toxic and smelly to you and me. But to the deep-sea bacteria that thrive here, it's good, wholesome nutrition. If life can thrive here in the dark, pressurized depths of Earth's oceans, what about other oceans, like the one on Enceladus?
For years, we have searched the planets in our solar system for signs of alien life. But perhaps it will be a moon that first confirms that we are not alone. Some moons have all the key ingredients for life: water, carbon, and energy. Energy not from the sun or from volcanoes, but from massive tides, crammed beneath the icy crusts and dragged around by Saturn's colossal gravitation.
Next stop, the moons of the gas giant Jupiter. Ganymede, the largest moon in the solar system. This big guy is covered with an icy crust, which hides an astonishing surprise. Perhaps more salt water than all of the oceans on Earth combined. And what's waiting for us here on the surface of our neighbor, Mars? These are actual images captured by the Mars Reconnaissance Orbiter that shows the red planet covered in topsoil. When the NASA rover Curiosity first scooped up a handful of this red soil, geologists thought it looked surprisingly familiar, like the soil back home in Hawaii. Mars has water, masses of it frozen at the poles and more buried within its soil. Water, carbon, energy from the sun. All the basic ingredients for life are here. That's why biologists wouldn't be surprised to find life on Mars. Not the kind with flying saucers and ray guns, but still fascinating, microscopic, and very real life.
They would have to be resilient, able to withstand extreme temperatures and a constant bombardment by radiation from space. Our own planet has a magnetic field and a thick atmosphere that largely shields us from deadly cosmic radiation.
When we humans make it to Mars, we'll need a lot of technology just to help us survive. But there are some residents of Earth that would thrive on the red planet. The water bear, or tardigrade, is a perfect example of extreme survivalist. A tiny water Bear Grylls. In the toughest test of all, these hearty little guys were launched into the frozen vacuum of outer space and blasted with severe cosmic radiation. Hostile to humans, but not to water bears.
I am constantly reminded of the tenacity of life. Perhaps life in our solar system is far more common than we realize. In 2022, an ESA spacecraft will take a closer look at Jupiter's moon Europa and its mysterious red cracks. Ice-penetrating radar will show us what lies beneath the surface of this strangely scarred world.
Astrobiologists constantly scour space for the conditions that support life. And their search doesn't end in our own backyard. It's beyond our solar system that the really exciting discoveries are waiting. These are the pillars of creation. Massive clouds of gas and dust. This cloud of dust is a star factory in our own galaxy, the Milky Way. It's in awe-inspiring places like this where nature churns out billions and billions of stars. And around many of those stars, planets, perhaps as many as 100 billion. And on those planets, possibilities.
Some of the planets we have already found are much older than Earth. Worlds more than twice the age of Earth. If such planets have life, it could have evolved much further than us.
This is the Kepler telescope, a remarkable planet hunter that has already discovered more than half the known planets beyond our solar system. But how?
With extraordinary sensitivity, Kepler is able to lock onto distant stars to detect if something passes in front of them. Tiny dots that dim the star's light ever so slightly. Tiny dots equal planets. Only a month into operation, Kepler found its first giant planets, all bigger than Jupiter. Slowly but surely, even though they are much harder to find, Kepler has discovered more and more small planets. And among those, the first potentially Earth-like worlds. The other amazing thing is that Kepler has found all these planets by searching only a tiny piece of the galaxy. Until recently, Kepler was always focused on exactly the same area of the Milky Way, spanning only 2% of the night sky. And in this tiny area, it has detected thousands of planets orbiting alien suns. I think this would have been one of Carl Sagan's dreams coming true.
Once Kepler has found evidence of a new planet, the data is turned over to astronomers back here in Hawaii. Giant telescopes can confirm Kepler's findings. Once confirmation has been made, telescopes can go further and actually observe distant planets. More than 120 light-years away, this small red dot is the very first alien planet ever seen by humans. It's nearly 13 times the mass of Jupiter and orbits around its own parent star. More and more of these distant planets are coming into focus. As our telescopes become smarter and more powerful, we might even spot a planet with a tiny halo, an atmosphere, and just maybe a thriving habitat for life. Lisa knows the procedure very well. In fact, she's writing the rule book on it.
When light filters through a planet's atmosphere, it creates a spectral fingerprint, telling us if the planet possesses the essentials for life.
We're living in a new golden age of space exploration. Over a dozen spacecraft have already been dispatched to Mars. If there's life there, we'll find it. The conditions for life are everywhere you look in the universe. And as our ability to see improves, so does our ability to discover and learn. The Messenger probe took a trip to Mercury, where it found frozen water on the surface. The Juno spacecraft flew 500 million miles to orbit Jupiter, where it's unwrapping the mysteries of the gas giant, which may actually have a solid core hidden beneath the storms raging across its surface. And as an encore, we've landed a spacecraft on a comet as it flew through our neighborhood on its long journey around the sun. And there we found something astounding and essential to human life: oxygen. And finally, scientists have now discovered an Earth-like planet in our neighboring solar system. We call it Proxima b. It doesn't get any closer to home.
Imagine that soon we could discover continents, oceans, and maybe the first sign of life on alien worlds. This is what Carl Sagan implored us to do.
Human endeavor and curiosity are helping us better understand our purpose in the universe. When we leave Earth's grasp and venture into space, we stand as one, representing all of humanity. Life out there might be microscopic, or it might be someone intelligent enough to find Voyager and listen to our message in a bottle.
Hello from the children of planet Earth.
I'd like to extend the greetings of the government and the people of Canada to to the extraterrestrial inhabitants of outer space.
Hälsningar från en dataprogrammerare i den lilla universitetsstaden
Vishe Shanti.
Hartelijke groeten aan iedereen.
Herzliche Grüße an